Okay, good day everyone. So we're back with forces, no? So we'll be discussing what forces are. Okay, sige. Force is a term given to an interaction of two bodies that causes their deformations or it will affect motion of the body. Okay, now we have different kind of forces. Generally, there are only two. So we have forces that is due to contact, no, or a contact or applied forces, and the other one is the non-contact, no, or field forces. No, so what is a contact force? No, so a contact or applied forces is a force, no, applied to an object by a person or another object. So like a person posing a block, no, the force is the force exerted on the table by a person. So they are termed as contact or applied forces. The other one is the field or non-applied forces are forces which are applied remotely. Example are the gravitational force of the earth and the electromagnetic forces coming from the lightnings. Now, so they are actually the two general classification of or two types, no, in the classification of forces. But forces can also be classified according to the effect. So how does the body be affected? So it can be affected externally. So this is forces which are actually acting and reacting forces. So reacting forces at the supports. No? Now the other one is the internal forces. They are forces resulting out from the externally applied forces. So this is an effect of the externally applied forces. No? So internal effect of which the force developed is what is termed as the internal forces. No? So we can classify them a force according to the effect of the force into the body. Now, another classification of force is in the manner of distribution. So, there are forces which is considered concentrated force or load, a force acting on a very relative or a relative small area considered as a point. The other one is a distributed load or force. They act on a relatively large area that could not be considered as a point, but acting on a larger area. So a figure will show a concentrated force or load and a distributed load. No? So pananglit kini. Your P1 and P2 here, no? So they are acting on a point. So they are terms as concentrated force or forces. But this one, so we have, this is actually a combination of a rectangular load, no? Because we can extend that up to this end together with a triangular loading. So we call this as uniformly distributed load while the other one is uniformly varying load. But if you consider your load from here up to here, so this is rectangular load, no? Uniformly distributed load, and a varying load which is a trapezoidal load. But if this is extended here, so you have a rectangular load together with a triangular load. So they are example of a distributed load. They are acting on a very large area, not considered anymore as a point. Now, another classification is according to the action as the load is applied. One of which is a tensile force, a force that causes elongation of the body. The other one is a compression force, no? A force that causes contraction of the body. So as to figure, so we have two kind of forces, no? As you notice, the force is applied towards the body and it is also counteracted by the same force, no? So we have two forces acting towards the body. The effect of this is actually to compress. So there is a shortening effect of the body when it comes to compression. So these are compressive forces. This one, if the load is applied on one end, so away from the body, and the other one also away from the body, so this is a part here which is actually subjected to elongation. And the forces involved there is actually tension. No? So with this, mao lang yapon. So if the force is directed away, so tensile force. If directed towards the body, then that is a force known as compression. So, scalar is a term. A scalar is a quantity. A scalar quantity is a physical quantity that can be described by a single element of a number field, such as a real number, often accompanied by units of measurement. A scalar is usually said to be a physical quantity that only has magnitude and possibly signs, no? and no other characteristics. So like, for example of which is an area, energy, time, mass, volume, and length, no? Etc. No? Then, force being a vector quantity, so we have to recall what a vector is. A vector is a quantity that does not only contain magnitude, it also contains magnitude and direction. And then it is represented with arrows. Example of a vector is a force. So as I've said, a force is a vector quantity. Velocity, acceleration, and moment vectors. No? So they are example of vector quantity. So what is important in a vector quantity? Doon na sa magnitude, the same time doon ay direction. No? So makita ni mong vector, it is represented with arrows. Okay? Now, what are the characteristics of a force being a vector? Actually, this is already mentioned kanina when we mention force, but just to show the characteristics individually, so the force has a magnitude. The amount of the force that is applied. Now, we call that as the magnitude. Then, it also contains direction. So, that refers to the angle between the reference axis and the arrow's line of action. We call that as the direction. And what is the third? The third is it contains sense. The sense is indicated by an arrowhead. So you will know the direction of the force, whether it's upward, downward, to the left, or to the right, as indicated in the arrow, directional arrow. No? Because a force is actually represented with arrow. So katong naa sa iyang tip of the arrowhead, so motoy mo ila kung asa pa dong imong force, whether it goes upward, downward, to the left, or to the right direction. Then, there is also a point of application. This is necessary to describe the effect of the force. Now, suppose there is a mass or a body that is mounted on a table, and then there is a force F applied at this point. Now, this is what is termed as a point of application. The sense is the tip of the, kanina imuhang arrow, the tip of the arrow. Okay, then, force equal to 50 kilonewton. The 50 kilonewton force there is what is termed as the magnitude. The angle from the horizontal or maybe from the vertical or a fixed line of reference is actually termed as the direction angle of your force. No? So from the reference so to the line of action of the force. No? So nga. Then we have the principle of transmissibility. This applies to rigid body. On a rigid body, a force can be moved anywhere along its line of action without changing its internal effect on it. Suppose, assume in a force applied, A causes the body to move to B. When a force is transferred along its line of action at a point in A, the distance traveled remains the same. No? So the distance traveled is the external effect nga iyang mapakita when a force is being applied into the body. Okay, here is the diagram. If a body A has a force applied F at this point, then the body travels to a position B. So this is the distance traveled with the body upon the application of the force F. No? So this is the distance traveled. Now, if this is the line of action, no, and then I have to put the location of a point of application of a force right here, no? So the same amount of force applied, then this will also travel on the same distance. The equal distances being traveled, so this is actually the principle of transmissibility. No? So as long as the force ko is applied on the same line of action, then the external effect of the force will remain the same. Okay, so distances traveled are also the same because of the principle of transmissibility. So this is applied to rigid body. Okay, so that's all. Okay, so thank you for watching and goodbye.